Good afternoon, my dear student. Good afternoon, my dear student. Today your last chapter means last part of this chapter, and for your last part of your syllabus. Okay? Electromagnetic induction. Before it you know it. Electromagnet, coil and solenoid. So many terms are there. Those are not in this part. Those are just in opposite nature. Opposite means when the current passing through the conductor, conductor creates a magnetic field. Okay? Magnetic field lines. So many terms are there. My dear student, you must be sincere about it. What is the properties of the magnetic field lines? What is the direction of the magnetic field when the current carrying conductor in the straight way, in the circular loop, and in the solenoid? So, solenoid and coil, you know it, and if you put it a soft iron core inside the solenoid, that time it will be an electromagnet. Without the soft iron core, the solenoid behaves like a bar magnet also. Okay. So my dear student, you know it. When the current passing through the conductor, conductor creates a magnetic field, and if the conductor is placed in a uniform magnetic field, conductor also creates some force. That force and direction of the force depends on the Fleming left hand rule. You know it. And the application of this is the electric motor. An application of this, the Baller wheel. You know it. Okay. So Fleming left hand rule, it is the first part of this chapter, and Fleming right hand rule is the last chapter. So electric motor and electric generator. Electric generator is not in your syllabus in this year, because you check your syllabus 2021, and most probably you see the school website, the syllabus, and also the CBSE site. The magnetic effect of electric current, the magnetic field lines, field due to a current carrying conductor, field due to a current carrying coil or solenoid, force on current carrying conductor. Fleming left hand rules, electric motor. Okay. Electromagnetic induction, the last part of this chapter. Induced potential difference means EMF, and induced current, and last part Fleming right hand rule. So electric generator and the household electric circuit not included in this year. So my dear student, you check your syllabus and you complete it. Okay. So electromagnetic induction. Induction means induced. Induction. I am here. Suppose you are there. You are motivated from my side. Your nature will be changed from my side. your behavior will be changed. This type of words you know it from your colloquial language. Birds of feather, birds of same feather flock together. Birds of same feather flock together. Okay, you know it. What is the inner meaning of it? Because suppose you consider a group of students are roaming here and there. If you know this, one boy or one girls are very, very disturbing, very notorious, very rubbish. That time you also consider it. Most of the students are nature at that time. Those nature are not that type. They are skipped from that group. Am I clear, yes or no? So, they are motivated. They are collect the bad things from that person as soon as possible. So, this is the induced. That person is the source, means mother, and that person is the created by that. This is the induced by that. Means, suppose you consider it, a current passing through the coil. A current passing through the coil. The direction of the current is this. If you put it a coil just nearer to this coil, you see the current will be induced, current will be created on that coil. The direction is opposite. Okay. Current will be induced on that coil and direction will be opposite. This is the induced current. If current is there, you know from your first chapter, current electricity, if current is in a conductor, when it will be create some current, potential difference is there. Means if the current direction is this, potential difference this and that point are different. That means VA must be greater than VB. So a potential difference create on that coil, that is the induced EMF or the induced potential difference. When the potential difference and the EMF will be the same, when the internal resistance of the cell will be zero, that time the EMF and the potential difference will be the same. Okay, my dear student, you know it from your previous class, from the first chapter of this electricity. So my dear student, induced current, induced EMF term totally new. So you check it. Suppose you consider a coil is here. Okay? A magnet, permanent bar magnet, you hold it nearer to the coil. Suppose this is not, that is south. Okay? The magnetic field lines create in this side, you know it. So it creates a magnetic flux. This term is totally new. You see in the upper class. Magnetic flux. So when it will be moved through the coil, that means the relative velocities is there. What is the inner meaning of it? The coil is rest. magnet is moving inside it. If the magnet is rest, the coil is just moving on it. If magnet and coil both are moving, but their velocities are different, that means the relative velocities are there. That time a current will create in the coil. This current is called the induced current. Okay, this was discovered by the scientist Faraday. This was discovered by the scientist Faraday. So we know this Faraday law of electromagnetic induction. First law: if the magnet moving inside the coil, that means change its magnetic flux, it creates some current. That current is the induced current. But second law, if EMF, induced EMF create in this part, means EMF or the cell, you see it, induced EMF create in it. When the current create on that coil, that induced create by the change of flux. So the induced EMF is directly proportional to the rate of change of flux. My dear student, I will try to clear you when the syllabus will cover the magnetic flux. Okay, only you know it, that term. The induced EMF created in this coil by the Faraday, it is directly proportional to a rate of change of a magnetic flux. So net change on the current carrying wire is 0. Then why does magnetic field exert force on it? Net change on the current carrying wire is 0. Net change charge, net charge on the current carrying wire is 0. Then why does magnetic field exert force on it? Net charge 0. F equal to force Q into V cross B. So if the charge is 0, that time magnetic pull exert a force. I don't know. Net charge on the current carrying coil is 0. If the charge is 0, that time no current will be created on this coil. Now when you are left. So I will try to check it. Okay. Net charge is 0. That means if you consider it is possible. Otherwise it cannot be possible. If the induced current in the coil means no charge is here, charge is created by the induced method, that time a force is created on it. That time it force is created on it. That force is depends on the Fleming right hand rule. And you know it, if the charge means current create in this direction, when the force acts on the magnetic field. Force acts means force of which type of force? Magnetic net charge is 0 in the sense that positive and negative charges are following opposite direction. No, that is the AC current. It is not this method. It is not it. Negative charge and positive charge is not the 0. Okay. I will try to discuss you for the AC part. It is your higher class. I also try to help you. Just today I will complete this syllabus, and next day I will try to give the answer. All the extra question from this chapter. Okay. So you see only here. This is the AC part. Faraday law of electromagnetic induction. This is the two laws, you know it, only you remember it. And this is the vital law. The EMF, induced EMF is directly proportional to the rate of change of magnetic flux. Magnetic flux also new term, you only remember it. After the complete the syllabus, then I will discuss those parts. So d dt of phi. Phi means magnetic flux. Magnetic flux. Change of magnetic flux, rate of change of magnetic flux is directly proportional to its induced EMF. But this is the law. One question is here from your previous part. You know it. If the north pole is here, the direction of the current in that coil, you see anti-clockwise, because anti-clockwise means it creates the north pole. You know it. If the direction of the magnetic current through the conductor in magnetic field, magnetic pole will be north. So this portion create a north pole. So north pole and the north pole of the permanent magnet opposed to each other. Okay, so you see here, it is the source, and that is the effect. So effect oppose the cause. Effect oppose the cause. So that is a very dangerous thing. So that law will change it by the scientist Lenz, L-E-N-Z. Lenz, he also put a sign, that sign is negative. That sign is negative. Negative sign indicates the oppose the induced current direction, means the north pole opposed to the north pole of the magnet, means bar magnet. So correction by the Lenz, discovered by the laws Faraday, and correction by the Lenz. So electromagnetic induction. Okay, you know in the great example for the electric generator and also the transformer. So many transformers, you know it in daily life. You see it, electric transformers, so many are here. One is the step up transformer, another is the step down transformer. Step up and step down transformer. So my dear student, you see the two types of coils are there. One coil is inside it, another coil is just side by side, not touch to each other. Am I clear? Not cross to each other. They are fully separate. And that depends on the number of wire turns on the coil. If you consider it, the step up transformer, that time the number of turns will be the more. So powerhouse to the domestic area, you see the step up transformer, and the roadside to the domestic area, you see the step down transformer. So this step down transformer also creates the 11,000 volt to the 220 or 440 volt. Okay, so you check it if it is possible. If it is possible, you see the two types of coils are there. One is coil wounded on a rectangular shape, anything, and another coil is also separate, and there deep in the a rectangular shape box, inside the box you see some oil is there. Why you use that type of oil? Now oil also control the heat of the coil. Control the heat of the coil. The coil will be heat because when the current passing through the conductor it will be heated, and due to this extra heat or the more heat controlled by the oil. So you know it, transformer oil, so many types of use for your medicine purpose. So in this chapter only you know it, what is the Faraday law of induction, and you know it, the Lenz correction, and next part you know it, Fleming right hand rule. Fleming the right hand rule, and the electric motor is not in this syllabus, sorry, electric generator, and Fleming the right hand rule just like a left hand rule. Left hand rule, this is the current, that is the magnetic field. When the current passing through this conductor in a uniform magnetic field, the current creates some force. The direction of the force is the thumb finger of the left hand. Okay, this is the just opposite. This is the uniform magnetic field. If the uniform magnetic field, a force is created on it, due to this force induced current create on the coil. That direction is perpendicular on it. So this is the effect, that is the cause, and this is the effect, that is the cause. So this is the generator. The mechanical energy change into the electrical energy. The mechanical energy creates some force on it. Mechanical energy creates some electrical energy. Electrical energy change into the mechanical energy. Okay. So my dear student, you remember it. Two laws, two fingers are different. Only the magnetic field, uniform magnetic field directions are same. So if you try to remember the electric generator, you also next day I'll try to, time is over. Okay, next day see you again today after this portion.